Hi everyone, thank you for joining me for today's webinar, number 28 in the English series, and it's the integrated solution concept for roll formers. So, your partner in the roll forming industry, Data M Sheet Metal Solutions was founded in 1987. We're specialising in software solutions and services for tube makers, roll formers and the related industries. We have two leading software solutions, Copra RF and Copra FEA RF, and they're for the design, simulation and analysis of roll form tooling, and these are used worldwide. We have some hardware, that's our Copra Profile Scan desktop, and that's for the inspection of profiles, along with our Copra Roll Scanner. Essentially they're both optical measuring systems for efficient quality control of products and roll tools. We're also a service provider for design, simulation and analysis in roll forming. We have international partner network and subsidiaries in the USA, India, Poland, Sweden and Great Britain. With regards to the integrated solution concept, we're looking now at the inclusion of the manufacturing process and how important and how vital this can be when looking at subsequent simulations. And in this example, we're looking at crash tube deformation behaviour, for example. So here in image A, we can consider the change of the part once you understand the material properties and the differences from the roll forming process. And here in image B, we can see an example of that, and this is a test considering only the original material properties. So no roll forming information is carried over there. And we can see ultimately the difference between the two results. A little bit more for you on the next slide. So here you can see the behaviour now in the two short videos. First of all, the crash test considering the modified material properties, the work hardening taking place during the tube forming process caused by roll forming. And over here on the right hand side, you can see again the effects now of the crash test considering only the material properties of the tube. So this would be a pure mesh, a clean mesh, not containing any information from the roll forming process. Essentially, Copra FEA RF simulates the entire production chain and makes these effects on the products visible. When we consider roll form profiles nowadays, we're not looking at the roll form parts of 30 years ago. We now look at parts with embossing. We'll look at parts with holes that are then roll formed and then welded. And of course, punch holes and embossings are changing the material's behaviour during roll forming significantly. Certainly, as you can see in the example here on the image on the right hand side, when the embossing is near to a forming bend, for example. And of course then we have to take steps to ensure that we have enough relief and clearance around those embossings in the rolls, to ensure that we don't flatten them out again during the roll forming process. So one of the key things here we can see, and this is a rather fast video, but Copra FEA RF simulates the entire production process with embossing, and it makes the effects on the products visible. So here I'll play this again so we can see the embossings going in a two-stage, and then the roll forming process through to weld and finish. So you can see the embossings applied, forming of the box section, and then finish. We can also consider the winding process. So let's, for example, consider an exhaust tube, a flexible manifold, where the tube is roll formed in flat form, and then during the winding process it's interlocked. And this is quite an intricate roll forming process, quite often done in a few passes, with sometimes high strain at strip edge, and we can sometimes find ourselves using this strain to help close the profile, to help it interlock during the winding process. However, clearly doing this without simulation, the shop floor, can take a lot of trial and error. So when we look at winding models, this allows us to remove lots of problems quite often found at the production floor during the design phase, And of course we're integrating the knowledge from the roll former itself, what's actually happening to the material into the winding process to help us optimize that fully to ensure we get a right first time solution. If we can consider dimpling of strip and ultimately minimizing the wear of roll geometry by looking at the detail of the dimpling, and of course we, by reducing forces reduce wear. And then when we consider this then passing through the roll former, again to ensure that it's not being flattened and the work hardening that's taken place isn't affecting the formability of the profile afterwards. An interesting one here, we're using Mark Mentat to look at press part analysis using the traditional method of stamping a roof bow for a vehicle. And in doing so, what we're also able to do, as you can imagine now, is we can look at this roof bow as a roll form product, not just a pressed part. And we can make comparisons. We can look at the difference in the stresses between the two by making a virtual test showing a part under bending load. And we can see the differences then that the work hardening that's taken place during the roll forming process has, and maybe sometimes the strengths and the benefits of roll forming over the pressed part. So we have a few more examples now of processes we've simulated at Data-M using Copra FEARF and the Mentat tools. So first of all, you can see here we have shearing as an example, welding of the part. An interesting one here, typically in processes like a bumper profile, inline bending as the part leaves, passing over rollers, maybe even with an internal snake in there. We're looking at the forming of 3D formed parts, maybe high frequency welding, and a hydroforming of a high frequency welded tube whereby the tube is inserted into a die, the tube is filled with oil under high pressure, and then the tube itself then assumes the shape of the die it's mounted within. Sweeping, we can see which could also then form into a helical form, quite often used for the liners of jet engines. And then finally you can see an additional one of stretch bending. So again, taking the information in each one of these processes from the roll train and applying it to its subsequent process. And stretch bending again, stretching the profile around a die, either as it leaves the roll former or as a secondary operation. And more recently, looking at form and roll deformation, actually understanding the deformation the rolls are going under during the forming process. And of course whether they're actually applying the forces that we'd like. Because we must remember that simulation nowadays doesn't start and end with the roll former as in previous times, and more people are looking at the pre and post operations, and these are becoming more important as organisations strive to remove a complete part from the machine and reduce second operations and of course costly material handling that goes with those second operations. So there's just a few examples of the processes we've been simulating with Copra FEARF. So it's key to understand that right now we're offering these sort of solutions as a service, of course, and also for people who may be doing this type of thing on a regular basis, we're also offering the possibility of being trained to do this yourselves within your organisation. You can follow us on Twitter for all of the latest information on product releases, exhibitions we'll be attending and webinars. A lot of our recent videos can be found on our YouTube channel at Data-M 2012, and more information about our company and employees are also on LinkedIn. So that leaves me to say thank you for your attention, everyone. I hope you found this webinar informative about some of the possibilities of the integrated solution with Copra FEARF these days. That was integrated solution concept for roll formers. Goodbye.